Hi folks, my name is Barnstedt. I'm the Chief Architect for Standards, Consortia and Industrial IoT in the Azure Edge and Platform team at Microsoft. And today I want to talk to you a little bit about digital product passports and how they can be built using OPCDI technology. So first of all, let's define the problem, or let's define the use case. So digital twins and digital product passports are meant for building resilient supply chains. So what does that mean? Well, usually when a supplier sends data to one of its customers, they need to pick a data format, and usually the supplier and the customer are not using the same cloud technologies. So for example, the supplier could be on Google Cloud, the manufacturer or the customer could be on Azure Cloud, and then the customer of the manufacturer could be on AWS. Or in fact on a government cloud, which is usually a sovereign separate cloud, not available on the public internet. So how does communication along those clouds really work for product information? And it's clear that we need to build a standard such that the exchange of data along those different cloud systems, enterprise cloud systems, let's call them, is as smooth as possible. And nowadays, obviously, we also have an additional requirement for providing things like the carbon footprint of a product, which needs to be calculated, including the footprint from all the parts that a product makes up, and all that data needs to come from supply chain. So again, if you really want this to work, clearly the data needs to be standardized such that you don't have to do a separate integration with each supplier that you have. So this is kind of the problem space, and OPCDI actually delivers all the building blocks required to build such a digital product passport. Here's an example specifically to a battery passport. And again, all the parts that are needed are available from OPCDI. Starting with the cloud library, it allows you to host OPCDI information models online. You can search through them and make sure that the information that you have in your digital product, if it's OPCDI based, which of course we all hope it is, then you can access references to the type information of the types used, for example, in that digital product passport directly from the cloud library. And you don't need to integrate and copy all the different companion specs into your digital product passport. You can just reference them. For the exchange, it's pretty clear that kind of the world has gravitated towards REST interfaces. So they're the most simple and the most widely used, especially when it comes to cloud-to-cloud communication or enterprise-to-enterprise communication. So OPCDI now also has a REST interface. And then finally, the ecosystem for building these digital product passports themselves with OPCDI technology is already there. There's several open source, free of charge tools available for building OPCDI information models. One of them, for example, is the Smart Manufacturing Profile Designer from SESMI in the US. But there's several different tools. There's one from Siemens called Sioma, which is pretty popular. Unified Automation has one. So I mean, really, there's a big ecosystem of tools already available, which makes it super simple to build these digital passports on OPCDI technology. So here's a little bit more about the cloud library. So already mentioned, SESMI uses it, but other people are using it too. SESMI has built it directly into their profile designer. So when you're creating a new profile or smart manufacturing profile based on OPCDI, you can load all the existing type information from the cloud library and then extend those types with new parameters or properties or whatnot. So it's relatively straightforward to build such a profile. And SESMI also integrates things like OPCDI and the asset administration shell with their profile designer. So it's super simple to then also export what you've just built in OPCOA and Asset Admin Shell format. So a little bit about the REST interface. So we started the working group a few years ago, and pretty much started from what was already there, right? So OPCOA had a REST interface since 2016. Not a lot of folks know that, and it was kind of buried in the spec. And now we have pretty much a brand new REST interface defined, which is mimicking a client-server interface. So you have REST interfaces for browse, read, write, a method call, historical read as well for historical data access and so on. So this is all available today. It's OpenAPI compatible. So we've used OpenAPI version 3, which is again the most popular for defining REST interfaces. And we've integrated this into version 105.4 of the OPCOA specification, specifically part 6. So part 6 will probably go into review this month, and then the standard 3 months review period starts. So by the end of the summer we should be able to have this available. And like any other OPCOA working group, we also built 2 prototypes as we're developing the specification to make sure that it actually works, and it's super simple to use. So we completed those, and as we're going to release part 6, we're also going to make the open source reference implementations available on the OPC Foundation GitHub. As important, especially given the fact that a lot of folks use open source today, and we wanted to make it as easy as possible to integrate the REST interface into your applications. So have a look out for the release of version 105, 105.4 specifically, and then have a look at GitHub, the OPC Foundation GitHub. It's just GitHub/OPC Foundation, and you'll see it there in the next few months. So it was a super popular working group. Lots of companies participated, and that also goes to show that there's real interest in using OPCOA for things like cloud to cloud and enterprise to enterprise communication for things like the digital product passport. So when did we start with building these digital product passports? Well, it kind of started in 2022 when we the OPC Foundation worked with the Digital Twin Consortium in the US and built kind of a digital twin leveraging the robot companion spec, or robotics companion spec specifically, and that was a joint effort between the OPC Foundation and the Digital Twin Consortium. A year later already, we then built the first digital product passport, again leveraging the work we did with the Digital Twin Consortium. We contributed the resulting reference implementation to the Digital Twin Consortium GitHub, so it's still there, right? So you can still download it and use it. And we used things like the Asset Admin Shell as the interface, and again this was before we kicked off the REST working group. So now we can also use the REST interface of OPCOA instead. So that's all there, and just a year later after that, again we built a battery passport. A little bit more on that in a minute, but as you can see, we really made a lot of progress in a short amount of time. Really, we started 3 years ago or 2 years ago, and we are at a very good place now with end-to-end solution for digital product passport using OPCOA technology. Sesame again was a partner, so was the VDMA, so it was quite interesting to bring all the different consortia together and build this battery passport. We did show it at HMI this year in April. So this is what it looked like. So we had obviously modeled the battery passport based on the 130 130 or 140 parameters that we actually received from Catena X, and we leveraged their work with the prototype that we built. We then built an OPCUA companion specification, or a node set file, let's say, specifically with those 150 properties, and then used things like the Smart Manufacturing Profile Designer from Sesame to actually define it. We then uploaded it to the cloud library. You can see it here as a publish button on this website, and made it available to everyone, right? So if you want to look at this particular tool for building things like battery passports, it's just available online, profiledesigner.sesame.net. Registration is free, so you can use it free of charge. And again, you can import all the models and export all the models from the UA Cloud Library, which makes it super simple to use and to share work amongst the community. So, like I mentioned, we built this battery passport and showed it at Hannover Messe. We worked with Huawei on that, so they provided the data of one of their industrial batteries. This is a 200 kilowatt hour battery, so it's a big battery. Just so you know, providing a battery passport for industrial batteries and mobile batteries, so anything over 2 kilowatts. So that includes things like, e-bikes and e-scooters and so on. It will be mandated in Europe to provide a battery passport by 2027. I think it's February 2027. So less than 3 years from now, all manufacturers of these batteries need to provide these battery passports. So this is a real, a real need to start building these battery passports. So Huawei is kind of ahead of the game, and they already provided the information here. And again, we managed to fill in the data in an hour, right, and build a battery passport with OPCUA in literally a day, right? So it was very, very simple, and if we can do it, so can you. So that was a good exercise and showed the capability of what we built together. So what does it look like in terms of the tool chain that you need to use? Well, again, you need obviously an OPCUA information model, and again, we built this for the battery passport based on the type information from Catena X. Then obviously you need the data from your supplier for the battery. We then created this smart manufacturing profile and then stored it in the cloud library. That's it. And of course, you can also import it into an OPCUA server, right? It's just a node set file. And again, use things like OPCUA file transfer to share it, or use the REST interface that I just described to share the battery passport with your supply chain, with your customers. So let's have a look at it. So this is a detailed description of it. So there's obviously things like product carbon footprint and recyclability information. There's also data about the capacity of the battery and its use. There also is a few pieces of live data that you can supply. So for example, state of charge, wear of the battery and so on. So there's quite a lot of detail provided. Some of it is optional, some of it is mandatory. And again, the whole thing is then bundled in an OPCUA server, or you can, like I mentioned, stick it in the cloud library and make it available from there. But obviously, the live data will require a connection to the battery in use. Again, OPCUA technology lends itself for that, and sending data to a online website, for example, where people can reach the battery passport is also simple with things like OPCUA pops up technology. So just using an MQTT message to the cloud via a broker would be the most obvious thing to do there. So this is, again, it was a prototype, but we're continuing to make that better and use it for different battery types and so on. So this is just the beginning, and we're planning to add a lot more functionality to this as we get more and more interest. So certainly there is interest from customers that I've seen, at least, because of the legislation, of course. So people want to get going with this and want to start. I recently read that Volvo for their XC30, I believe, is already providing battery passports. And it's super simple to access it as an end user as well. So there's a QR code on the door, and so you can just scan the QR code with your phone, and then that'll bring you to this, for example, this website, right? And it's super simple to access, and this is part of the mandate from the European Commission that accessing this information for the end user should be super simple. And again, scanning a QR code doesn't get much simpler than that, right? You don't even need to remember the website. So this is kind of where things are going. And again, from a usability point of view, obviously you want to make it as simple as possible, right? So this is also important. Where the data comes from and all of that should be abstracted, and the user should be presented with a clean user interface where all the required information is readily available. So then let's have a look at where this fits in the overall architecture. So this is kind of something that I developed over the years because people always asked, how does digital product passport fit with OPCDI, and what about on-premises and enterprise cloud and so on? How does it all fit together? So this is kind of an overall architecture. So from left to right, on the left you have the production line building a product, right, from a certain manufacturer. So you have machines and you have an MES controlling those machines. And nowadays, and of course on top you have an ERP database, which will usually sit in an enterprise system, either on premises or in the cloud. In this case, I drew it in the cloud, but it can also be on premises, not a problem. And the MES will then also extract information from the ERP system. But then nowadays with Industry 4.0, obviously you have a cloud connection, and this is done through an edge gateway. And you would have things like the cloud publisher and the cloud commander. So the cloud publisher publishes data from machines in a PubSub format to a broker, and the cloud commander receives commands from a cloud broker and sends them on to the machines in OPCDI client server technology. So if, like I mentioned before, not every machine has an OPCDI interface. So if your machine doesn't have an OPCDI interface, you can use industrial connectivity software. And the OPC Foundation has a reference implementation called UA Edge Translator that will basically translate to OPCDI from any proprietary interface. So this is kind of what the edge looks like, and then in the cloud you usually have two components. You have a broker which receives messages, and you have some sort of edge management application that allows you to deploy applications to the edge and manage them and so on. Then connected to the cloud broker is a time series database, and that time series database may feed a digital twin service, right? So again, a lot of people use digital twin technology for defining their production line hierarchy on a worldwide basis, but you can also go one step further and define all the assets that you use in that hierarchy. There's a tool that I wrote and contributed to the Digital Twin Consortium called UA Cloud Twin. It allows you to upload the ISO 95 models to a digital twin service, either in DTDL or Web of Things format. So this is something a lot of people want. They want to use things like ISO 95 to model their digital twin. So this is where that fits. And finally, I mentioned the cloud library a few times in this presentation. This is basically where the cloud library sits. It feeds information, for example, into your time series database, so you can associate your messages from your machines, for example, for the live part of the battery passport, and associate that with, for example, the battery passport noteset file that you can make available in the cloud library, either in the cloud library hosted by the OPC Foundation or a private instance. So you can use both. Then, of course, you have some sort of product database, which define what your product is made up of, including bill of materials and so on. And you're probably going to have some sort of dashboard that shows production information, like for condition monitoring, OE calculation, stuff like that. And then, of course, you can analyze the data using AI-assisted tools. This is pretty common, and then take action on that analysis. For example, to optimize your production line, and for that, we've also provided a reference implementation called UA Cloud Action. And then finally, we get to the digital product passport, which then extracts information from things like the cloud library and the time series database for the real-time part, but also the product database and so on, and the ERP database to get bill of materials and you know, the order, who ordered the product. All of that will end up in the digital product passport, for example, the digital battery passport. And again, you can use things like the asset admin shell with an OPCOA information model, or you can use the OPCOA REST interface to model your battery passport. And finally, behind my picture here is the customer's ERP system, which can then extract the information directly from the website that I showed you earlier on through its REST interface. And this is basically how the whole thing fits together. So with that, final slide, please consider joining the Cloud Initiative. The reference architecture that I just showed you will also feed into the Cloud Initiative. It's a new initiative kicked off by the OPC Foundation for accelerating use of OPCOA in the cloud, and most major cloud providers have joined already, and a bunch of end users, so please consider joining and bring your requirements to the table.